Hello, everyone. I'm Xiaoyun Wang, and from the University of Texas in San Antonio, and I'm presenting today this a tool demonstration called VRTest, which is an extensible framework for automatic testing of virtual reality things. So first of all, let me give you some background information. So virtual reality is an emerging technique allowing various applications. Those applications include training, education, visualization of data, visualization of systems, and also entertainment and games. So UI testing of virtual reality applications has been a very challenging problem, especially compared with traditional GUI testing. There are several reasons. The first one is that the VR things, they typically have much larger search space than the traditional GUI widget or window. You know that GUI windows are like 2-dimension, while the VR space is 3-dimension. So you're adding just a 1 dimension and also like one level of magnitude. Also in the VR things, or which VR things are actually the basic components of VR applications, just like Windows in traditional GUI applications. So in the VR things, objects may occlude with each other. So for example, you can have a object like a cube that is occluding a button, or maybe not a button, but an interactive object. I'm just using a button to make it like a comparable analogible with the traditional GUI software. So if you consider an interactable object can be occluded by other things, that is the issue with VR things. But you don't typically have this problem in GUI testing because if a button is really being occluded by another button, then that button is not accessible at all, right? The third thing is object may move. It's very common that the interactable objects in a VR things are moving from one place to the other place while you are playing the VR thing. So in this true demonstration, we are going to introduce this VR test. Our goal of this VR test is providing automatic test framework for Unity VR applications. In particular, Unity is widely used. Actually, now has over 60% of market share for VR applications, and it is kind of like a dominating SDK for virtual reality. So the features that VRTest supports, including tracking all the interactable and non-interactable objects in the VR things. Remember that we need to also know where the non-interactable objects are to avoid them to be occluding, or to find the real interactable objects to bypass them. And the second thing is the VR test implements basic camera features such as rotating, moving, and point clicking, so that for controlling the software, for controlling the camera. And the last one is the VR test is providing a callback-based interface, so that if you have any other test strategies, you just can control the camera with the rotating, moving, and point clicking, and based on the information that VRTest provides, and so that you can just focus on the test strategies. So this slides we give an overview of our framework. So you can see the VR thing is what we are testing, and use the laser pointer, and then we use the VRC monitor to gather information from the thing, and then the information is being sent to the exploration controller. And this exploration controller is going to send out the virtual object instrumenter to instrument the objects inside the thing, and then that information will be updating the VR thing with the state change reporter to basically tell the exploration controller what information is, what objects are have been visited and have been accessed. And we can see that the exploration controller has 3 callback functions: move, turn, and trigger, and they all and we have they all supporting different testing techniques. So for each test technique, you're going to implement the move, turn, trigger callback functions, so that you can control how the camera is going to move and trigger objects in the VR thing. And we also have a test configuration interface that can give some basic information that the exploration controller needs to follow. Okay, so the VRThing monitor, which is the first component that we have, it basically tracks all the virtual objects in the thing, including the creation of objects, destruction of objects, and it represents all the virtual box with bounding boxes. So the bounding boxes is like a box that can, like a rectangle, a box that can enclose our virtual objects, because our virtual objects can have different shapes. Right? So we are using rectangle boxes to make things simpler for the testing strategies. And the second part is the VR object also instrumenter. So our VR object instrumenter automatically adds listener to the interactable objects. And that also including, for example, when an interactable object has been created, right? So we got the information, and then a listener is going to be automatically added to that object. So the listener will update the exploration status when the object is triggered. This listener, you can see from the code sample below, is basically a listener, and whenever an event is being triggered, it is going to call a like update trigger function, and that update trigger function is going to update our thing information about whether the object has been triggered and how it has been triggered, and also how many times it's been triggered. So finally, the exploration controller actually inserts the VRTest code into the lifecycle of the VR scene in Unity. So on the right-hand side, we can see this is the VR scene lifecycle of Unity. So basically, a VR scene is being initialized at the beginning, and then every frame, it's basically about 0.02 second to 0.03 second. Then a physics update is going to be executed. That is being executed every 0.02 second, basically means 50 times per second. And then the logic updates, that is going to be executed based on the FPS. And typically the code of the VR application goes here, right? So we can see that that is how, and to the end of the thing, then you some like ending code of the thing is being executed by the Unity. Okay, so we can see this is the life cycle of the thing, and we have two places to insert our VRTest to control the camera. One is the physics update, the other is the logic update. We're putting it in the physics update because physics update is mainly for physics movement, which is what our camera is doing. And also, when the code is being put into the physics update, it is going to be executed 50 times per second, and will not be influenced by the logic updates, which is mainly affected by the actual code of the application, the VR application. And we provide 3 callback interfaces: the trigger, the rotate, and the move, which are here inside the physics update. So basically, we are first to fetch the exploration controller is first fetching the camera state and checking if the action is finished. If it is finished, for example, moving from A to B is finished, then it is going to ask for the test strategy to find out what is the next move I should do, right? And also including instrumenting new objects, new found objects, newly created objects. But if the action is not finished yet, then the exploration controller is going to finish the action. It should be noted that a movement, for example, from A to B of the camera, needs to be finished within many frames. So, for all of those cases, actually this N or no branch is being executed. So that's why our exploration controller needs to handle that inside the update function. So then, as the test configurations, we have 3 major test configuration values for the developers to set, including the moving rotation scope that defines the size of the thing, so right where the camera can go. And the second one is the moving rotation speed. That mainly depends on how fast the video the developer wants to see after the testing. And the moving rotation granularity, that is mainly related to whether the objects in the thing is typically large or small, that should be comparable to the size of the objects inside the thing. Okay, so those are the three configurations. We have default values for all of them, but developers can easily change them. So our VRTest framework also provides two built-in strategies, which are pretty simple, but shows how VRTest can work with different strategies. We have the VR monkey, which basically just random explore the thing, just like the monkey in the Android. And whenever it finds the object, it's going to point-click the object. And we also have the VR grid, which uses a grid algorithm to always move to the closest and triggered interactable object. And once it's triggered, then the strategy no longer consider that. Okay, so these two test strategies have been implemented. So here is the evaluation. We can see that we are trying the two strategies in 5 different VR applications, and these are from GitHub. They have like about from hundreds of lines of code to tens of thousands of lines of code, and with like tens to hundreds of virtual objects. And we can see that the comparison between VR Monkey and VR Gray shows that the VR Monkey is able to access only about 20% or less objects, where VR Grid is able to cover more than 50% of all the objects. Okay, so the conclusion is that VRTest is an extensible test framework of Unity VR apps, and the VRTest is able to incorporate different test strategies using the 3 callback functions as interface. And the tool implementation is available as open source also, and you can just download it and extend it with your own test strategies. Thanks, and we have the lab demo.